In this video, we want to see if this series converges or diverges. First, we're going to use the direct comparison test. So we want to compare this to either something bigger or smaller. How do we know what to compare it to? Well, let's look at the biggest degree at the top and the biggest degree at the bottom. Clearly 5n is the biggest degree at the top, and the biggest degree in the bottom is n cubed. So this is 5 over n squared, and by the p-test we know that this is going to converge. So we need to compare it to something that is going to converge. So something like 1 over n squared. And we'll go over the details in a second. But this tells me that it's going to converge, and the form of that the comparison should be something over n squared. Okay, so this is what I do. If I want to get something bigger, I have to make the denominator smaller and the numerator bigger. So n squared minus 4, I'm making the denominator smaller. N squared minus 4 is going to be greater than or equal to 0 when n is greater than or equal to 2. So this is positive, or non-negative. That means if I remove it, I'm going to get bigger because I'm dividing by a smaller number now. So that takes care of making the denominator smaller. Now for the numerator, this is a way to do this. Always put the lower degree term into the higher degree term. So the highest degree here is n. So why don't you make 11 into 11n? We know that 11n is greater than or equal to 11 when n is greater than or equal to 1. So here we're looking at n equals 2. So this is, we're in good shape. We can do that. You never want to make the degree higher than what it was previously. So it wouldn't make sense to say this will be 11n squared. You can't do that. You always want to put it the degree at which the highest degree previously. So here it was n. Now 5n plus 11n is 16n. 16n over n cubed is 16 over n squared. So this is what we're going to compare it to. And we know that this converges by the p-test, since p is 2 here. And so by the direct comparison test, this series will converge as well. Now let's use a limit comparison test. Well, what shall we compare it to? For the limit comparison test, you don't need to be specific like this. So why don't we just compare it to 1 over n squared? And I chose to divide by 1 over n squared. Technically, you can also have done 1 over n squared over the original series. But the reason I did this is because dividing by 1 over n squared is the same thing as multiplying by n squared. And so n squared has to multiply the 5n and the 11. So for that we get 5n cubed plus 11n squared at the top, and the bottom stays the same. Now because we're looking at n approaching infinity, we really care about the highest degree at the top and the bottom. So you have 5n cubed over n cubed, and we know that's equal to 5. My limit is 5, it's positive, and it's less than infinity, so therefore by the limit comparison test, this series converges.